Welcome to this explainer. Okay, today we're diving straight into what I'm calling the ultimate survival guide for homeowners. We're zeroing in on the absolute unsung hero of your house, the HVAC system. To really figure out how to protect our homes, our sources point us to this fascinating case study in extreme environmental survival, specifically looking at Lakewood, Ohio. Let's see what happens when a heating and cooling system is pushed to its absolute breaking point. Now, the crucial piece of the puzzle here is geography. Lakewood sits less than a mile from Lake Erie. Just think about that for a second. What happens to a home fighting a literal daily battle against a massive dynamic body of water? Well, it means the systems inside are fighting wars that inland houses just never have to face. It is an environment that actively wants to tear mechanical equipment apart. Picture this scenario, and we've all had that nightmare thought. It's 2 a.m. in the middle of a brutal, teeth-chattering January freeze, and suddenly, your furnace just dies. Or, on the flip side, imagine it's a sweltering July heat wave. The humidity is thick enough to cut with a knife, and your AC unit completely quits. This is the ultimate stress test. It's pure panic, right? Because when these systems fail, they don't do it conveniently on a Tuesday afternoon. They fail when they are working their absolute hardest. And looking at the specific local threats in our case study, it makes total sense why these failures happen so dramatically. From November through March, heavy lake effect snow just dumps massive moisture loads on heat pumps and furnaces. Then summer rolls around and that exact same lake generates intense humidity. That forces AC units to work overtime, not just cooling the air, but literally wringing heavy moisture out of it. Plus, you've got severe freeze-thaw cycles stressing out the components and salt-laden winds coming right off the water that literally eat away at the outdoor metal. Add in century-old housing stock with, let's face it, outdated leaky ductwork and seasonal debris like leaves and those little helicopter seeds clogging the coils. The environment is just a relentless antagonist. So under all these brutal conditions, what actually breaks? The sources highlight some major mechanical casualties, and the first one is basically a silent killer. It's called short cycling. This is when a system turns on and off every few minutes, over and over again. Why does that happen? Usually, it's because the equipment is oversized for the house, or the coils are filthy, or there's a refrigerant leak. The end result is that the system never runs long enough to properly pull the humidity out of the air. Plus, that constant starting and stopping rapidly burns out the compressor and the motors. And get this, all that constant strain can actually trigger our next casualty, frozen evaporator coils. I know, it sounds totally crazy, but your indoor air conditioning unit can literally turn into a block of ice right in the middle of summer. The mechanics here are fascinating, but super destructive. If you have restricted airflow, say from a dirty air filter or crushed ductwork, or if you're running low on refrigerant, the pressure and temperature inside drops so much that the ambient moisture in the air freezes right onto the coils. Eventually, the system just gives up, starts blowing warm air, and starts leaking water straight through your ceiling. Okay, so a frozen coil is incredibly messy, for sure. But this next issue we found in the research, it's downright dangerous. We're talking about cracked heat exchangers. Over years of those intense freeze-thaw cycles we just talked about, the constant expanding and contracting of metal causes metal fatigue. Eventually, the metal just fractures. And why is this such a big deal? Because those cracks allow combustion gases, including deadly, odorless carbon monoxide, to mix directly with the breathable air blowing right into your living room. This is the hidden vulnerability of older furnaces. It's exactly why getting an annual professional inspection isn't just a nice-to-have recommendation, it's absolutely critical for your family's safety. So, you're standing in front of a broken, freezing, or cracked unit. What exactly do you do? Well, the source material revealed a highly practical rule of thumb to help with this exact moment. Just burn this number into your brain, 5,000. This is known as the $5,000 rule, and it is a total game changer. It's designed to help you make quick, rational financial decisions right in the middle of a chaotic breakdown. Here's how the math actually works. You take the age of your system in years and multiply it by the estimated cost of the repair. If that number comes out under $5,000, you go ahead and repair it. If it's over $5,000, it makes way more financial sense to just replace the whole unit. Let's do a quick example. Say you have a 12-year-old furnace and your tech says it needs a $500 repair. Well, 12 times 500 is $6,000. That's over our $5,000 threshold, which means, yep, it's time to replace it. It's just a brilliant, simple formula to stop you from throwing good money at a dying system. There was another fantastic piece of insider advice in this survival guide, and this one comes down to a single digit 3. This is the 3-minute rule. Here's the deal. If you ever manually shut off your air conditioner at the thermostat, or if the power flickers during a storm, never, ever restart your AC immediately. You absolutely must wait at least 3 minutes. See, when an AC shuts off, the refrigerant inside the system is highly pressurized. It needs a little time to equalize. If you force it to restart instantly, the compressor has to fight against all that trapped high pressure. Doing that causes massive, completely avoidable wear and tear and can literally lead to immediate compressor failure. Now, good quality thermostats have this delay built right in, but if you're operating an older one manually, seriously, keep an eye on the clock. Okay, let's say your system failed the $5,000 rule and you've got to bite the bullet and replace it. You are immediately going to be hit with a wall of industry jargon. So let's translate that right now by looking at the Department of Energy's minimum efficiency baselines. For air conditioners, particularly in northern states, the minimum standard is 14 SEER. For furnaces, the minimum standard is 80% AFUE. But what do those acronyms actually mean in plain English? Demystifying this is so important so you feel empowered rather than just overwhelmed by contractor talk. SEER measures cooling efficiency. Simply put, the higher the SEER number, the less electricity the unit uses to cool your house. Think of it like miles per gallon on a car. Now, AFUE measures furnace heating efficiency. This is literally the percentage of fuel the furnace actually converts into usable heat. So an 80% AFUE furnace turns 80% of its fuel into heat inside your house, while the other 20% escapes straight up the exhaust flue. High-efficiency models nowadays can reach up to 95% AFUE, meaning almost zero wasted energy. But hey, the best strategy here? Avoiding a total replacement for as long as humanly possible. The data clearly shows that proactive maintenance is a mathematical necessity. It's really not a luxury. Regular tune-ups stop something like 85% of breakdowns before they even happen. They catch failing parts while they are still somewhat working. And just look at the numbers. Annual maintenance actually extends the life of your equipment by a massive 40% and cuts your monthly energy bills by 15%. It literally pays for itself. Sometimes, though, extreme weather wins, and you have an emergency. When that happens, you need to know how the professionals bring order to the chaos. A reliable service uses a structured 3-step process. Step 1 is immediate dispatch, meaning no waiting for days just for a callback. Step 2 is expert diagnosis with professional tools, followed by upfront flat rate pricing before anyone even picks up a wrench, so there are absolutely no surprise fees. And step 3 is comprehensive system testing and providing a written warranty. That ensures the fix actually holds up through full heating or cooling cycles. All right, before we wrap up, the sources shared one ultimate strategic takeaway. If you know your system is aging out, please do not wait for it to die during a blizzard or massive heat wave. The absolute best time to buy a new HVAC system is during the shoulder seasons. We're talking late fall, like October and November, or early spring in March and April. Contractor demand is at its absolute lowest, equipment availability is high, and you, the homeowner, have all the negotiating power. So, we've seen exactly what happens when extreme geography tests the absolute mechanical limits of our homes. From using the $5,000 replacement rule to following the 3-minute compressor rule, you now have the structured knowledge to make smart, proactive decisions. So, I'll leave you with this thought to consider today. Take a quick walk outside, look at your outdoor unit, listen to your furnace. Is your HVAC system silently losing its battle with the elements right now? And if it is, what are you going to do to help it win?